Okay, this is the last of the packets. This is naming acids. Acids generally start with H. Now, if you saw this, HCl with a G for gas, you would name this the way you've been naming everything, hydrogen chloride. But now, if you saw HCl with an AQ for aqueous, remember aqueous means dissolved in water. That means it is now an acid. And this is a binary acid. You see only two elements. You see hydrogen and one other element. So this, how do we name these? It's hydro plus the element plus ic. So the name of this one would be hydrochloric acid. Another binary acid would be H2S, aqueous. Two elements, one of them is hydrogen. So this would be hydro plus the element, so this would be hydrosulfuric acid. Hydrosulfuric acid. If you had H3P aqueous, that's hydrophosphoric acid. Remember, these are binary because there's only two elements. Doesn't matter how much of each element there are, right? Hydrogen and phosphorus, hydrophosphoric acid. Now, suppose it's an acid that has an oxygen in it. That's called an oxy acid. Those are going to come from chart E again, the polyatomic ions. So if you saw H2SO4 aqueous, if it was a gas or a solid or something else, you would have said hydrogen sulfate. So sulfate, if it came from ATE, the acid is going to end in ic. So if it comes in chart E, and you saw 8, it means the acid name is going to end in ic. If chart E ended in ITE, that means the acid would end in us. Ic-ate, us-ite. Some people remember it as I got sick when I ate it. Ic-ate-a-site or whatever. So this, H2SO4, this is a tertiary. There are three elements. Tertiary acid. So there's no hydro in the name. H2SO4 is sulfuric acid. If it had been H2SO3, SO3 comes from sulfite. That would be sulfurous acid. This rule applies with all of them. If you had H3PO4, that would be phosphate. That means the acid ends in ic. This would be phosphoric acid. HNO2. HNO2. I look on the chart. Do I see NO2? Yes, I see nitrite. So if this is aqueous, it is now ic-ate-us-ite, nitrous acid. Now remember before I pointed out the hypochlorite, chlorite, chlorate, and perchlorate on the bottom of chart E. Those can all be acids. HClO, HClO2, HClO3, HClO4. ClO with a charge of -1 is what? Hypochlorite. So this would be hypochlorous acid. Remember, we're assuming these are all aqueous. ClO2 was chlorite, so this would be chlorous acid. ClO3 is chlorate, ic-ate-usite. hydrochloric acid. HClO3 says perchlorate. This would be perchloric acid. And one more thing with this, you could take the Cl and you could change that with Br, and you can change that with I, and you would have hypobromous or iodic acid. You have any of those choices. And the last, very last packet is hydrates. Hydrates like CuSO4.5H2O. That means you have copper sulfate and 5 water molecules attached to it. So this would be copper. And remember, copper comes in 2 charges. In this case, you reverse the crisscross, you get copper 2 sulfate. And you use the Greek system. There's 5 waters, so pentahydrate. So you name the first part the same way we've been naming from the first day. The number in front of the water comes from the Greek system. So 5 would be pentahydrate, 4 would be tetrahydrate, and the water is always the word hydrate.